Are we good? Good to go? Okay. All right. Where was it? Yeah. So Dagger. Yeah, it's not new, but a lot's changed in Android development and in Dagger in the last year or so. So a lot of this talk does assume that you are vaguely familiar with Dagger or have used it before. But even if you haven't, I hope you come out with some sense of how to start adding it to your Android apps. So just quickly, what is dependency injection? So dependency injection is basically, instead of writing code that looks like this, you write it so it looks a bit like this. And that lets you pass, say, an interface instead of a concrete type. And that has a bunch of advantages, like it makes your code a lot easier to test. You can see everything this class depends on by looking at its interface. If you had to write all that code by hand to plumb all that together, it's going to get pretty tedious pretty quickly. So what a dependency injection framework like Dagger lets you do is mark up your classes and your constructors, and then it's going to go away and generate all that boring plumbing code for you. You can also write provides methods, and you can bind interfaces to concrete types and put these in a module. And in Dagger speak, what we're doing here is we're creating a binding, and a binding is a sort of a key that's a type and telling Dagger how to get an instance of this type. And bindings, like a component pulls all these bindings together. It encapsulates a set of bindings, and within a component, a binding is available to any other binding. And when you write a component, Dagger's actually going to generate the class that's an implementation of this with all that plumbing code. So components, they can have methods in their interfaces, so you can get bindings from outside of the component. You can also annotate them with a scope. And that means when you annotate your bindings with that same scope, you'll only have one instance of that binding in that component. Singleton is one built-in one. You can also have custom scopes. So components, like this component we just saw, it's standalone. It doesn't depend on anything else. But you can also have component dependencies. And when you make one of these, this component can depend on any binding in that first component's interface. And so when you made this other component, you had to pass an instance of the first component. That's not the only way. Components can have subcomponents, and with subcomponents, they have access to any binding within the parent component. It doesn't have to be exposed in the interface. A way to kind of think about this is a subcomponent's a bit like an inner class. So just as when you're writing normal Java code, if you had an inner class, you can have multiple instances of an inner class for one instance of the outer class, and the inner class can access any field, even if it's private, in the parent class. And actually, under the hood, that's exactly what Dagger's doing. It's for each subcomponent, it's going to generate you an inner class. Whereas with a component dependency, you're passing it in like any other dependency, so it can only access those things that are exposed in its interface. So that's Dagger. But what about on Android? And we've been using Dagger in the Citymapper app for a few years now. We started with Dagger 1 and then moved to Dagger 2 a couple of years ago. But I don't think we've ever had a Dagger 2 setup we were really happy with. I mean, if you just go on the internet and look like, how do you put Dagger in your Android app? You'll probably see something a bit like this. So we have our app component, and we add an inject method. Oh yeah, so Android types, they're instantiated by the system, or by the framework itself, and that means they have to have an empty constructor. So we can't do constructor injection, even though constructor injection is what we usually prefer. So we have to use method injection. So here, to do this, we've added this inject method to our app component, and then in our activity, say, we can expose that as a field in our application class, and then we can go get our application class, get the component, and inject ourselves. Or if we're in a fragment, we can do pretty much the same thing. And that works, but it's not always enough. Activities and fragments, they have a life cycle. They're created and destroyed. And we often want to scope things within that life cycle. So say like we have a list of restaurants here, we might want to also show them on a map. But that map could be in the activity and not the fragment, but we're loading the data here, say. So how do we get that map? So in Dagger, to create a scope, the easiest thing to do is a subcomponent. So here we can make our activity subcomponent, and then we can use this other Dagger feature where we can add an instance as a binding when we create it. And then in our activity, fairly similar, but this time instead of just calling inject, we're making a new instance of this subcomponent, passing our map view, and building it. And then in the fragment, instead of just getting the component from the app, we look it up from the activity and call inject. But there's an issue here, like that just go get the activity. Why does this fragment have to know that it's in this activity? What if it's a nested fragment and the subcomponent's in its parent fragment? I mean, we can kind of make it a bit more generic. And I mean, that's what we did. We made this injector thing, and it can just look at its parent fragment, or you can make like an interface like has component that your activities and fragments could implement. And then you can look up your parent fragment and your activity and then the app until you find something that you can get a component from, and then inject this. But you still have to know that this is a map activity component. You still have to know the type of your component that you're looking up. And that's fine, it kind of works. And this is what we had for ages. And we kind of had this one like big God activity component that could pretty much inject most things in the app. But then some screens, they needed their own subcomponents because we needed things to scope them. But then you had shared elements within a screen, like the map or like the bar that comes up at the bottom of the screen when you're offline. And so everything needed to know how to inject those. So we had all these interfaces that all these subcomponents had to implement so that you could look up the right thing and inject it, and it kind of got a bit out of hand. I mean, I think once you've got something that looks like this in your code, you know that you could improve somewhat. And that's not all. Like in the last year, things have started to change in Android development. Android Studio 3 came out, and with that came a new way, they revamped the way that the Gradle plugin handles dependencies, and then they said, oh, write your code in lots of small Gradle modules, and it'll build faster. And there's also instant apps, and like you might be thinking about, oh, how can you start thinking about how to write an app so that in the future you can make it an instant app? And again, that needs you to split your big monolithic app module up into lots of little feature modules. So that kind of just makes all this more of a pain. Suddenly we're like managing all these subcomponent interfaces everywhere, and we've got a way of composing things already through Dagger modules. Why should we have to do both? But what is wrong here? And if we look at the Dagger documentation, it says this: a class shouldn't know anything about how it's injected. But we've already violated that. We know that we're looking up this component and we're calling inject. So that's not working. So is there anything that Dagger gives us that we can use? Sorry. And it turns out there are a few things, and they've been working for a while to provide a few more mechanisms to sort of build these subcomponent hierarchies. And if we just take an aside and look at a couple of other Dagger features, this one's fairly new. So like I said before, usually when you make a subcomponent, you add like a subcomponent methods to your component interface. Well, they recently added this. So instead, you can actually specify a subcomponent in your module annotation. And then that makes the builder for it available as a binding that you can use anywhere in the component where this module is included. There's also these, which are multi-bindings, which are actually really useful features. And how it basically works, if we have a set multi-binding, you can have these 3 provides methods that all say int a set. And then you have a binding for a set of strings. And if you inject it, you get that set with 1, 2, and 3. So that's interesting. We've got a way of adding making bindings available in modules. And we've got this multi-bindings. And actually, lo and behold, in Dagger 2.10, they did the first release of Dagger Android, which actually takes advantage of all this to make injection on Android easier. And yeah, so it's a part runtime library and a part new annotation processor that you can add. But how does it work? Like, what does it add to Dagger that's not there already? Well, say you have an app that looks a bit like this. So you might have your service, a service, and an activity and a fragment that has a couple of nested fragments inside it. Oh, sorry. So before, we probably just had this like one big God activity component that could do injection on all this, and they'd go look it up, or they might look it up from the app. What Dagger Android is going to say is actually, why don't we just have a subcomponent for every single one of these? And that's kind of nice in some ways. It means that if you ever need to realize that you need to scope something within an activity or a fragment, you've already got one there. Before we had to go, all right, oh no, now we need to refactor this out so it has its own subcomponent, and it's a fair bit of work. But if you had to write all that yourself, that's going to be a lot of boilerplate code. And you don't want to have to do this every time you make a new screen. So actually, it wasn't in the original Dagger Android release, but soon after they added this. A new annotation, contributes Android Injector, which you use just like this. You have a Dagger module, and you add an abstract method and annotate it with that, and it returns your Android type that you want to make a subcomponent for. And that's going to tell Dagger to go away and generate a subcomponent. And that subcomponent can have modules, and it can have a scope. And in this subcomponent it generates, it's automatically going to have a binding for we made one for a map activity, it's going to have a binding for a map activity. And you can access it, and like here we're instead providing that map view this way. You can also nest these contributes Android Injector, and this is going to tell Dagger, please go away and generate another subcomponent for this fragment inside this activity subcomponent. But that's all well and good. That's generating a whole lot of code for us. We barely have to write anything. We don't have to like figure out all these interfaces anymore to do the injection. And we can just compose modules just like we do for any other dependency in our Dagger graph. So yeah, so to do the injection, the easiest way is to just make your base classes extend from these classes that Dagger provides. And you've got one for fragment, you've also got service, broadcast receiver, content provider. And if you do that and annotate your fields with inject, everything just works. Love this GIF. But we don't usually want things that are just magic, and it isn't actually just magic. There's nothing in these classes that you couldn't write pretty easily yourself. And in fact, they're just provided to save you some boilerplate if you need to use them. In fact, when we first introduced Dagger Android in our app, we didn't want to do the migration all at once. But if you extend from these, then you're going to have a contributes Android injector method for every single activity and fragment, so on, in your app. And we didn't want to do that all at once, so we just wrote the code that's in here ourselves where we needed it. But what is in these? So this is Dagger application, and it's a fair bit of code. But that's kind of just because it has to deal with all these different types. If we just look at the activity bit, say, it's quite short. So what is here? So it's implementing this has activity injector thing. And then it's just injecting this dispatching Android injector class. And that's it. But what is this dispatching Android injector? And if we look at the code, I mean, this is kind of a TLDR version, but all of the extra code is just error handling. But this is the important part. And we see it's actually just a wrapper around a map that has some fairly nasty generics. And then we just inject an instance. We just get a class key from that map, create a factory, and call inject. Still fairly straightforward, but where does that map come from? Well, I said earlier that what contributes Android Injector is doing, it's going to generate a subcomponent for you. And this is actually what it generates. And you don't even have to use contributes Android Injector if you want. You can just write this yourself, and it'll work. So there's the subcomponent we talked about for the activity, but it also generates this. And that's, and remember that multi-binding thing we talked about? That's basically what this is doing. So here's that map with the fairly nasty generics again. And what's happening is this is just going, hey, make a binding, multi-binding with a key of map activity, and then put this builder as the value in this map. And that's it. So it's using things that already exist in Dagger, and just adding a few convenience classes essentially and a bit of annotation processing, and it's going to go away and generate these subcomponents which are automatically added to this map. And if we look at Dagger activity, it's pretty much the same, just this time with a fragment injector instead of an activity injector. And it's also got this, which is kind of the last piece that ties this all together. And this is basically what we had before, that generic lookup system. All it's going to do is look up the app, which implements has activity injector, grab that dispatching Android injector, call inject on it, which will go look up the key for this activity in that map, find the subcomponent builder, build it, and inject this activity. And same for the fragment. Like this one's, it just, instead of calling Android injection, we just call Android support injection because it's a support library fragment. And it's just going to go look up its parent fragment, see if it implements, has fragment injector, and then the activity, and then the app until it finds one, grabs that map, builds its subcomponent, and calls inject. So great, we've reduced the amount of code we have to write significantly, and nothing has to know about how it's injected anymore. And yeah, this has been great for us. We started using it a few months ago in the Citymapper consumer app. We've just built a new app where we used it from the start. And then all that pain and having to think about your sort of Dagger graph and how it works is all gone. We just add these contributes Android injector methods and it works. No thinking required. But there are still problems. And that's kind of just due to how Dagger works. We kind of have to look at how it works to figure out why. So subcomponents, and actually just normal bindings. Say we have this, say this is a Gradle module, and it exposes a Dagger module and a subcomponent. And then in our app, we make a subcomponent that includes that module and and the subcomponent. Well, remember that all Dagger is doing is generating and implementing this interface app component and generating the code behind it. So when it generates it, all the bindings from that library module are going to be here in the Dagger app component. And because subcomponents are just inner classes, they're also going to be in this file. And that means when Dagger's generating this code, even though all those modules and all the bindings and the provides methods and the subcomponents are in the library Gradle module, Dagger can't generate any of that code until it generates the app component. And if anything changes, it's going to have to generate that whole thing again. It can't just generate bits of a file. So yeah, so that's not hugely great for build speeds. And that is probably the main issue that we face at the moment. Especially with Dagger Android, it really hits your build speed. There's also this. In Android Studio 3, they introduce implementation dependencies. And if you listen to the advice of the Android team, they're like, oh, use these everywhere because it's going to make your compiles more efficient. And it's also kind of handy. Say this is your a payments Gradle module, and it has a dependency on your payment processor's SDK. You don't really want all the classes from that SDK appearing in your autocomplete unless you're working in the payments module. So that's really useful, right? Until you try and expose one of those classes in your Dagger graph, and suddenly when you try and build, you hit this. So, oh, that class file cannot be found, which kind of makes sense. We know that Dagger's generating all this code in our app module, and we've also just told it that only the library can see this class, so it fails, which is annoying, especially when we started to hit this. And you can work around it. You can kind of wrap things in other classes. It's kind of a pain. And what can we do? Well, we could actually do this. Subcomponents aren't the only way of composing scopes in Dagger. Since the beginning, and actually before I think they had subcomponents, you have component dependencies. And so you could make a whole component for your library and just expose the classes that you actually need to expose through this component. And there's nothing stopping you from doing this. In your app, you could have a provides method that just builds that whole component and exposes the library class. And that's actually going to mean that Dagger can generate all the dependency injection code for that library or for that Gradle module when it builds that module itself, which is cool, and it can make your build fast as well. I'm not saying do this for everything. It's a bit of extra work, but if you have a big sub part of your app that's kind of standalone and has lots of internal dependencies, then it's an option. There's also this, the Dagger team are aware that there's these problems with build speeds and with everything trying to get more incremental in the future. This is actually from the Dagger AMA on Reddit from, I think, last week. And Ron Shapiro is one of the core maintainers of Dagger. So they are trying to figure out how they could compile subcomponents in separate files to make it faster. And lastly, instant apps. So we've just got this whole new great Dagger Android thing. But it still kind of needs all these subcomponents and all these bindings to be collected into one app component at compile time. But then if you've looked at the instant app documentation, you'll see that, oh, instant apps, you actually have this like base feature and then separate feature modules. And these feature modules have to operate as completely standalone apps. When the code from one feature loads, the other features might not have even been downloaded yet. So there's no way we can have this one big component with all the subcomponents inside it, because, yeah, they can't see each other's classes. Well, I said that Dagger Android is just kind of a few helper classes, essentially, on top of normal Dagger. So, yeah, I had to play around, and you can do something like this. You can make a component for each feature that has a dependency on the base app component. And then you can take the built-in classes that Dagger gives you and turn them into multi-feature versions. And yeah, I had to play around, and there's a proof of concept that works. It's not in production, so I make no guarantees. But it's just to show that even though they have built something and it seems quite rigid, the classes underlying it are quite flexible, and you can customize it. So yeah, that's me. Like I said, I lead Android at Citymapper, and we have our consumer app, and we just launched a cool new service where we're running our own network of vehicles, which launched yesterday, and we need help to make it bigger and develop cool new things, not just Dagger. So yeah, thanks. Questions? Do we need a mic for questions, or? Oh.
All the pieces of code you've shown are written in Kotlin.
Mm-hmm.
Does the Citymapper app is fully written in Kotlin?
No. Most new code is, and we're trying as fast as we can to get it there. But yeah.
Okay, thank you.
I thought I love Kotlin, and so I figured, yeah, why not write your slides in it? That's what everyone's doing these days.
I probably just missed it, but this was pretty overwhelming for me personally.
That's fair enough. There was a lot of code. But
I was led to understand that one of the big advantages we were going to get with Dagger was testing. With
yes.
mocks and the dependency injection at real-time, unit-time injection of mocks. Did I miss that?
So yeah, I didn't actually talk about that specifically. I think there's been a lot. I think there's been a lot said about Dagger and testing, and like the Dagger Android stuff doesn't hugely change that. I mean, you still can have your test components and modules, and in everything, it makes it a bit easier because instead of having two ways of sort of specifying how you're providing dependencies, like both the interfaces on your components and your modules, you just have one way. So it's kind of easier. And actually, like if we're writing unit tests, we don't use Dagger. We've already got those constructors, so we can pass dependencies in. So in our unit test, we just pass those dependencies. We bypass Dagger altogether.
That's it.
So at the end, for the Android support injection for fragments, you implement as fragment injector?
Yeah, so that's a class that Dagger Android provides.
Yes,
yeah, it's built in.
You implement it for each fragment and even in the activity. And I was wondering why you just don't implement it only in the application.
Oh yeah, so that's because, I mean, there's nothing stopping you from just doing it in the application, but then you can't, for example, have a activity subcomponent, so an activity scoped component, and then a fragment, say, scoped subcomponent inside that, and then you could have things that, you could have objects that only live within the activity that the fragment can access. You could only have like singleton things that exist for the whole lifetime of the application.
Okay, because I'm doing everything in the app, so maybe I have this problem.
Yeah, like we used to be kind of lazy. Okay, we made an activity one, but it was a pain to make all these subcomponents, so you kind of get used to working around it. But once you, I think, start using Dagger Android, it just makes that a whole lot easier. So you find yourself going, oh, I need this in my activity, and I need one instance, and I want it to be shared with all the fragments in it. But I want a new one for each activity, and then that's why you can, yeah, that's what that has fragment injector is for in the activity. And same in the fragments, you can have as many nested scopes as you want that you just compose together.
Okay, thank you.
Oh. All right, thanks everyone.